Assalamu alaikum, my dear students. Welcome to your chemistry second paper class of standard 11. Today I will discuss about Gay-lussac's law. What is Gay-lussac's law? The pressure of a fixed mass of a gas which have fixed volume is directly proportional to its absolute temperature, that is Kelvin temperature. That means the pressure exerted by a gas is directly related to the Kelvin temperature, where volume and mass of gas are constant. Follow the picture. Here, at less temperature, that is 200 Kelvin temperature, pressure is 1 atmosphere. And follow this picture. Here, the molecules are moving but in slow rate. But when the temperature is increased, that is 400 Kelvin, then the kinetic energy of the molecules are also increased, and for this the created pressure by these molecules are also becomes double. So from this experiment it is proved that pressure is directly proportional with the temperature. Follow here, when temperature is 200 Kelvin, pressure was 1 atmospheric pressure. But when temperature becomes double, that is 400 Kelvin, pressure also becomes double, that is 2 atmospheric pressure. So, this experiment proved the Gay-lussac's law. That is, pressure is directly related to the Kelvin temperature of gaseous substance. Now, mathematical expression of Gay-lussac's law. According to law, we can write pressure is directly proportional of its Kelvin temperature. And if we use proportionally constant K, then we can write P equal to Kt or P by T equal to K. And if we consider more gaseous sample, in that case we can write P1 T1 and it transfers into P2 T2 etc. And in that time we can write the formula like this way: P1 by T1 equal to P2 by T2 equal to K. And this is the mathematical expression of Gay-lussac's law. Now we will see the graphical representation of Gay-lussac's law. If we draw a curve between pressure versus Kelvin temperature, following the Gay-lussac's law, that is P equal to Kt, then we will get a straight line curve which is origin going at constant volume. And these straight line curves are known as isochord. So the graphical representation of pressure versus Kelvin temperature according to Gay-lussac's law becomes a straight line passing through origin, and this type of curves are known as isochord. Now there are many real life examples in which Gay-lussac's law is implemented. Among them I will discuss about 2 examples. First one, tire of motor vehicles. What do you know? If you measure the pressure of inside tire before starting the journey, that means at cold stage, because previously the temperature was cold before starting the journey, and now if you measure the pressure, then you will get a pressure, suppose that is 200 kilopascal. And after completing the journey, if you again measure the pressure of the tire, inside pressure of the tire, then you will get increased pressure. Suppose it is 220 kilopascal. Why? Because here temperature is also increased after journey due to continuous friction of tire on the road. due to continuous rubbing the tire on the road, temperature is increased, and for this the inside air pressure of the tire is also increased. So here easily we can observe the implementation of Gay-Lussac's law. That means pressure is directly related with the temperature. Now follow the another example, and that is using of pressure cooker. Nowadays almost all families are used these kitchen equipments to cook food quickly. Why? Or what is the mechanism of pressure cooker, or why less time is needed to cook food using pressure cooker? Here actually when we cook food in an ordinary pot, then at normal atmospheric pressure temperature rises more to boiled food items, taking more time. But if we use pressure cooker, then what will happen? At this increased pressure, the trapped steam becomes more hotter in quickly, and which cook food in very short time. For this, generally pressure cooker is used to cook or to boil the food in less time. Here the increased pressure inside the pot is actually increases the temperature quickly. But the two points are very important in case of pressure cooker, and that is the due to pressure rises it can cause an accident, that is explosion can be happened if the continuous rising of pressure is happened. For this, a pressure cooker has a valve that allows some vapor to escape when the pressure exceeds the set value. For this, after some times through the valve some trapped steamer comes out to drop down the pressure when it is becoming exceeds the inside pressure. To remove the explosion or to resist the explosion, this valve is set. So now we can easily understand here in this mechanism of this pot the Gay-Lussac's law is implemented. Now I will discuss about some problems based on Gay-Lussac's law. For example, an oxygen cylinder can stand up to a pressure of 250 atmosphere. The cylinder is filled with oxygen gas at 125 atmospheric pressure and 27 degrees centigrade temperature. At what temperature will the cylinder explode? At first you have to understand the problems. Then you have to start solution. So what is written here? A oxygen gas cylinder can resist maximum pressure of what? 250 atmospheric pressure. But the oxygen gas is filled in this cylinder at 125 atmospheric pressure at 27 degrees centigrade. That means P1 125 atmospheric pressure and T1 27 degrees centigrade. And what temperature will the cylinder explode? So, and this is the P2, value of P2, and we have to determine the value of T2. So we will solve this problem like this way. According to Gay-Lussac's law, we can write P1 by T1 equal to P2 by T2. Here P1 is this, P2 250, T1 is 27 degrees centigrade, and we have to convert it into Kelvin temperature by adding 273. So we will get 300 Kelvin. Now putting the value in the formula, we can easily determine the value of T2, and that is 600 Kelvin. Now it is the answer, but it will since the temperature is mentioned in your problem in degree centigrade unit. For this you have to again convert it into degree centigrade unit due to subtracting 273 from 600. So you will get 327 degrees centigrade. So up to this 327 degrees centigrade it will not explode, but the above 327 degrees centigrade temperature the cylinder will explode, because at this maximum tolerating pressure the temperature is 327 degrees centigrade. So above this 327 degrees centigrade it will be exploded. Now follow the next math. A gas cylinder with safety valve is filled up with fuel gas at 23 degrees centigrade and 0.99 atmospheric pressure. The safety valve will open when the internal pressure becomes 1000 torr. This is also unit of pressure. Whether the safety valve will open if the gas cylinder will be placed in boiling water at 100 degrees centigrade. That means there is given T1 and P1 and also T2. So you have to determine here P2. Follow the solution. P1, T1 you have to convert into Kelvin. Always here you have to convert temperature into Kelvin scale, and T2 also. So putting this value you will get P2 pressure 1.25 atmospheric pressure. But here is a clue. The safety valve will open when the internal pressure of cylinder becomes 1000 torr. So you have to at first convert the atmospheric pressure into torr, and we know that 1 atmospheric pressure equal to 760 torr. So from this relation we have to determine the value of 1.25 atmospheric pressure into torr, and we will get 950 torr. And there is a limitation. That means the valve will open when the internal pressure becomes 1000 torr, but at 100 degrees centigrade the pressure becomes only 950 torr. So the valve will not be open. If it becomes more than 1000 torr, then it will be open. But since the obtained pressure is less than 1000 torr, for this the valve will not be open. Now follow the another example. The relative density of carbon dioxide gas at STP is 22 kg per meter cube. What will be the density of carbon dioxide gas at temperature of 11 degrees centigrade and at constant pressure? Follow the problems. Here pressure is constant and what is given? Density. So this is just little bit different. In Gay-lussac's law pressure is variable, but here pressure is constant, so volume must be variable. So actually this is the problem related with the Charles law. So from the relation between temperature and density we will get actually d1 T1 equal to d2 T2, and this relation we established in previous class of Charles law. So from here we can easily do the math. D1 is given, T1 also given, T2 also given. So we have to determine the D2 directly, putting the value of other factors. So like this way you can easily solve this type of problem of density. So my dear students, I hope you can clearly understand the Gay-lussac's law and also different problems based on this law. So I kept here some extra problems to practice at home. That means this is the SW of this lecture. So you will try to do these problems, try to solve these problems and send in your group. Today up to this. Thank you.